Let's go to Code Milkers. Today we are on problem 21, and the problem name is leftmost column with at least a 1. This is an interactive problem, which means that you're interacting with a predefined user interface. In this one, it's an object called binary matrix, and you have to solve the problem using that object as the user interface. I solved this problem already. I did not feel confident when I saw it that I could solve it in under 30, so went ahead and solved it. I'll go over my answer here, though. So let's go over the question. So a binary matrix means that all elements are 0 or 1. For each individual row of the matrix, this row is sorted in... When I hear matrix, I can't help but think of the movie. This row is sorted in non-decreasing order. Given a row-sorted binary matrix named binary matrix, return the leftmost column index, 0 indexed, with at least a 1 in it. If such index doesn't exist, return -1. You cannot access the binary matrix directly. You may only access the matrix using a binary matrix interface. So our two methods that we can interact with the binary matrix object are get and dimensions. Dimensions returns a list of two elements, n and m, in an array. So the matrix is the size n times n. Now, get actually returns the element of the matrix at the certain index you provide, so x by y. X is the row, y is the column. So just for instance, if we looked at this example here, we have our matrix and we have two subarrays. We have 0, 0 and 1, 1. If we wanted to get this first element here, we would invoke binary matrix.get 0, 0 to get the first element. So that's how we can access elements and see if it's a 1 or a 0. Submissions making more than 1,000 calls to binary matrix.get will be judged wrong answer, so optimization is a problem in this problem. Also, any solutions that attempt to circumvent the judge will result in disqualification. I wonder if anyone's going to beat that. I think someone will. I didn't bother trying, but okay. For custom testing purposes, you're given the binary matrix mat as input in the following 4 examples. You will not have access to the binary matrix directly. So in this example, the column which has the leftmost 1 is the 0th column, because the top, like if from left to right is a row, we want to find the leftmost column that has a 1. So it won't be this column, it'll be this one because it's closer to the left. This one, for the same reason, it's the column on the right that is the leftmost because it has a 1. This example, there are no 1s, so we return -1 because we didn't find a leftmost column that even had a 1. And then example 4, we have our first row. It does have a 1, but it's in position 3, so we got to see if we have a closer one. Then we have row 2. We have a more leftmost column with a 1. Then we have our final row, which has the leftmost column in position 1. So we return 1. So we have constraints. The mat length will not be less than 1, and it will not be greater than 100. Any element of a subarray will be 0 or 1 because it's binary. And probably the most important constraint is that the elements in the mat subarray are sorted in non-decreasing patterns, so it's ascending order. So if you encounter a 1, or if you encounter a 0, you know exactly where to go based on that. If you encounter a 1, you want to move to the left of it to find an earlier one. If you find a 0, you need to go to the right. of it to find the first left you can find. So for my solution, I'll be honest, I did not know where to start with this problem because of that interface portion of it. So I clicked on show hint 1 and it said to perform a binary search. So I went with that type of solution here. So I'll run you through it. So here's the function that's invoked when we run the test cases. It takes binary matrix. We have no control over the matrix. We can only use the accessor methods on it. I defined the constant recurse and reassign answer. So I stored the answer, so the value you want to return, I stored that in its own variable that could be modified in the recurse function. I did this because it has to start out undefined for us to eventually be able to return -1 or the leftmost column that we found. Because we want to find the smallest column number, and if we started answer at equal to -1, we would never find a column that was more left than that one. So we have to start it at undefined. Or we could start it at the maximum infinity. That would work too. So here we define the mid. That's pretty self-explanatory. If the current element is equal to 1, we need to either reassign the answer or not. So we go to reassign answer, and if answer is undefined or it's greater than the current index that we found, we will reassign answer to the index. If not, we just reassign answer to itself. Then we recurse to the left of that 1, because we want to make sure that there's not a more left column that also has 1 for that particular row. And then we just return an arbitrary value. It doesn't matter. I return -1. If the array size is 2, then we need to check if either the low indexed value or the high indexed value is 1, and then reassign the answer accordingly. And here we have gotten to the point where we have no more elements to traverse over. And then finally, we are recursing to the right if none of these if statements are satisfied. We are recursing to the right, so imagine we have the element in the middle. We are then taking the subarray to the right of it as the new portion to recurse on. And then here, this for loop is how we do the recurse for each row. So we start at the first row and we go down from there, and we're just recursing on every row, and then the recursion method takes care of going through each element. So let me submit. And it works. Let's check out the time complexity. It was running 44 milliseconds earlier. So 60. Okay, so anywhere between 44 and 60 probably. And it seems like a good, I think the memory usage could have been less. I think that's going to be pretty high space complexity for this problem, but I think the runtime is pretty good if it can be lowered to 44 consistently. Hope this helped. Have a great day.